Hello. Okay. What's up, everyone? How's it going? How's it going? This is gonna be Half-Life worksheet. Yeah, let's get into it. First things first, I want to go over is this is the formula that you guys want to be using. Uh, yeah, A equals A naught is that's A zero times one half to the N. Um, uh, is there another one? Or is that it? Yeah. Um. Where is it? Okay, wait, here you go. This is n. It can also be t over t over one half right here. Which is just like the time passed over the half-life of substance. Okay. Uh, so let's just put this bad boy over here. Sweet. Oh, sweet. Okay, so right, as you said before, n equals t over t one half. That's just like the time passed over the half-life. All right, so let's go. Number one, what is meant by half-life? So half-life, just the definition of it, it's on the slides and everything. So half-life is the time required for one half of the original substance of the original not substance, original radioactive atom to decay into atoms of a new element. Right. This is in this slides right here. Half-life, right? The time required for one half of the original radioactive decay, radioactive atoms to decay into atoms of a new element, right? So, um, over here we have a 100% right there, and then half-life is when we get to like the 50. That's when we get to the 50 because 50 is one half of 100. That's one half-life, so it's the time for one half of the substance to decay. All right, so let's go. Number two. You have a two-step question. Oh, three-step question, A, B, and C. So you have 100 grams of radioactive isotope with a half-life of 10 years. How much of the isotope will you have left after 10 years? And so you actually don't need to do any math because like, you can like conceptualize this, right? Um, the half-life is 10 years, right? And the you start out with 100. So after 10 years, right, that's just one half-life. You're gonna have half of the original substance in 50 grams. And we can also like write this out in an equation if you guys want to. So A naught is, I believe, the original substance. Yeah, the initial amount. So it's gonna be your initial amount's 100 times one half, and then the n right here, we're just gonna put it as t over two to one half, or t over t one half. So after the t on the numerator is the time elapsed. That's gonna be 10 years, and the half life is 10 years. You plug this in your calculator, right? One half to the one, which is just going to be 50. Okay, so how much of the isotope you have left after 20 years? So after 20 years, that's two half-lives. You can still put this in the equation. 50 or 100. That's initial amount times one half. The time elapsed is 20, and the half-life is 10. So it's going to be 100 times 1/2 squared. And this will give you 25 grams. And you can conceptualize this as well, because half-life is just 1/2, right? So after 1/2 life in problem A, after 10 years, which is 1/2 life, after that 10 years, that whole half-life is one full half-life is completed, you have 50 grams left. And then for B, 20 years is 2 half-lives because it's 10, right? That's 1 half-life. And then 10 again, which is 2 half-lives. And so you go from 100, after 1 half-life, it goes down to 50. After 2 half-lives, it goes down to 25. How many letter C, how many half-lives will occur in 40 years? So this will be so okay, so we can also write down the equation like this. So we have 100 grams, that's the initial amount. And then, or no, actually, all we need to do is just do T over T, right? Over here. So time elapsed is 40, and then the half lives, what's the half life of the substance? It's gonna be 10. So 40 over 10 is just 4 half lives. So hopefully you guys are like understanding this relatively, right? Because 1/2 after 10 years, that's 1 half life. 20 years, that's 2 half lives. 30 years is 3 half lives. 40 years is 4 half lives. All right, number 3. The half-life of plutonium is 24,300 years. If a nuclear bomb released 8 kilograms of isotope, how many years will it pass before the amount is reduced to 1 kilogram? Right. Uh, so we have a initial, we have final, and then we also have the half-life. So we need to see like what's the time, how many years have passed. So technically, we need to be solving for this t up here, the time elapsed. Okay, cool. Um, so let's just plug and chug. We start with 8 kilograms times, and then for the exponent, the half-life is 24,300. Oh, all over x. Oh no, x over that. And then we have the final amount, which is 1 kilogram. You just plug and chug in your calculator. Oh wait, actually, actually taught a secret trick. So in order to do this, you can divide both sides by 8. And 1 over 8 equals 1/2 x over 24,300. And you would know that 1/8 is just 1/2 cubed. So 1/2 cubed equals 1/8. So we would do this in order to have the same bases. So it's 1/2 cubed equals 1/2 x over 24,300. Right. And so now we have the same bases. We can just solve with the exponents. So 3 equals x over 24,300. X is going to be 72,900 years. All right, sweet. Moving on, number 4. The half-life of radon 222 is 3.8 days. How much of a 100-gram sample is left after 15.2 days? So we have the half-life right here. We have the initial amount, which is 100 grams. And then we have the time elapsed. So time elapsed is 15.2 over 3.8. That's our N. Our initial amount is 100. That's 1/2. Right? And we need to find how much is left. So we need to find the final amount. You just plug this in your calculator. right? 1/2 to the 15.2 over 3.8 power. You're gonna get 6.25 grams. Hopefully, you guys know. Hopefully, you guys are getting the groove, the chemistry groove right now. All right, moving on. Um, Carbon 14 has a half-life of 5,730 years. Sample contains 70 milligrams. Originally, how much is left after 17,190 years? So we have the time elapsed. He has a half-life. And then we have the original. So 70 times 1/2. Right. And for our N, it's going to be time elapsed over half-life. And then we need to find our final amount. Still plug and chug, 8.75 milligrams. Sweet. If you guys don't know how I'm getting this stuff, like if I'm just saying plug and chug, and you like, well, Mark, that doesn't help, then just ask me, text me, call me, come to my house. Actually, don't do that. But yeah, and just yeah, and I'll walk you through it. Number six, the half-life of cobalt 60 is 5.26 years. If 50 grams were left after 15.78 years, how many grams were in the original sample? All right, so here we have the half-life. Uh, we have the final amount, and then we have the time elapsed. Uh, oop, what the? Wait, hold on. Oh, here we go. And then we have the, that was weird. All right, 15.78 years. And then we have the time elapsed. So we need to find the original sample, right? So it's gonna be x times 1/2. And then our n is gonna be time elapsed, which is 15.78 years. And then we have the half-life, which is 5.26. And then we have our final, which is 50. Um, so yeah, you just plug and chug. First, I would calculate this, and then I would just divide both sides by that, and then whatever, just divide both sides by that to find x. So x will be 400 grams. All right, number seven, the half-life of this thing is 8.07 days. 25 grams are left after 40.35 days. So this will be our final. This will be our time elapsed. How many grams were in the original sample? We need to find our initial. So our initial, we need to find our initial 1/2, and our n will be right time elapsed 40.35 over half-life, which is 8.07. And then we have our final, which is 25 grams are left it. So same thing, figure out what this is, divide both sides by that by divide both sides to isolate x. Yep, x equals 800 grams. All right, so number 8. 100 grams of AU decays 100 grams, right? So this is your initial. Decays into 6.25 grams in 10.8 days. They're our final. This is our time elapsed. What is the half-life of AU? 198. So we need to find our half-life. Time elapsed is 10.8 days over X, because that's our half-life. We don't know that. 1/2. Our initial is 100 grams, and then our final is 6.25, right? Divide both sides by 100. That's going to be give you 0 point uh 6.25 divided by 100 is 0.0625. And I believe this is also like Yeah. 0.0625 is also known as 1 over 16. So we can also rewrite 0.0625 as 1 over 16. So 1 over 16 is also 1/2 to the fourth power. Yeah, equals 1/2 to the 10.8 over x. And so now we can just rewrite it as this 10.8 over x. Isolate x, and then we get 2.7 days. All right, that's Half-Life worksheet for you. Let me know if you have any questions. A little bit of fast one. Yeah, happy studying. Ba-ba-da-ba. Woo-hoo.